Hi, I'm Fuko. One thing that TanStack people love to do is tag support. So here I will be answering Anthony's question, who wants to know how to add real-time syncing to TanStack DB. From what I understand, they have a Node.js backend and a Postgres database, and they probably don't want to rewrite their whole backend just to implement real-time syncing. I think the most minimalistic approach that you can do here is to use Electric. Electric has a product called postgres-sync that is a sync layer that sits between your database and your clients. It will watch the database for changes and make sure that all the updates sync to the client's real time. What makes it really easy to recommend Electric is that the creators of TanStack DB are actually from the Electric team, Kyle and Sam. I think they got in talks with Tanner after they heard what Tanner's vision of TanStack DB was, because it was very similar to what they had in mind for their own client-side library. This is probably the time to mention that if you don't know what TanStack DB is, you can check out trytanstackdb.com, which is an interactive tutorial that I made, and it can get you up to speed blazingly fast. Also in the news, I am actually a TanStack 4 maintainer. I just haven't been that active recently because I'm trying to shift my focus to knowledge sharing. I think we really need to make some of the cool TanStack stuff more approachable. It will be a longer video, but the timestamps will be in the description below. You can jump around if you want to. I will start by explaining a setup with TanStack DB and Query, and then I will show you what to change to make it work with Electric. I think it's just a better way to explain things, but you can jump right to the Electric stuff using the timestamps below. I will shut up now and let's get started. If you look at this diagram, you can see the whole process. From the database through the API, we sync the data in the project's collection, and it will distribute the data to the components that consume it. Now, what happens if we want to update something like the name of a project in project details? It will, first of all, optimistically update the cache in project's collection, and simultaneously it will send a request to the API to update the changes in the DB. And this is where we persist the state. After the changes happen, we will have another sync request that goes from the DB through the API to the project's collection. So this is the default syncing mechanism for optimistic mutations in TanStack DB. Now, when we use Electric, we will want to change some things here. Electric will sit in front of your database. Whenever something changes, Electric will send an update to all the clients that subscribe to it. Here's the problem though. Electric has all the sensitive information that your DB has. So you have to authenticate the requests, and you cannot expose Electric directly to the clients. To solve this issue, we will create something called the electric proxy, and the electric proxy will be a part of our API, and we will make sure that every request that should hit Electric will go through it. Now you can see that all the syncing happens through Electric, but the rights didn't change. This is because Electric is only concerned about keeping your clients up to date, and all the rights are handled by you. So if you need conflict resolution, you have to implement it yourself. Finally, we're getting close to the fun part, which is coding. We will have to first set up the connection between our DB, which is going to be Neon, and Electric, and then we will create the Electric proxy, and then we will update the collections to use the Electric proxy. I'm going to be cheating here a bit because I've already set everything up, but I can show you how it works. So basically you visit electricSQL's homepage, and if you go to cloud, which is, okay, so this is an important detail. You can self-host Electric yourself, but the cloud is their managed offering, and I think it's a much better way to use Electric because they know how to run it. So I will just use the cloud. And here you can create services. So let's click on new service and let's select postgres-sync. And here you can either provide your connection string, which is the way to go if you have DigitalOcean or a PlanetScale, and you can connect Neon by clicking on this button. I've already did it, so I won't click it, but it's very, very, very easy. One thing to note is that not every database is compatible with Electric out of the box. You might have to tweak some settings. I had to do it with DigitalOcean when I tried it. It's not hard at all, but it's something that can throw you off for sure. Before we go further, we need to discuss the concept of shapes in Electric a bit. Shapes let you define subsets of your data that you want to track for changes through URLs. This is really good news for us because it means that we don't have to fetch the whole database whenever anything changes in it. We can just listen to the changes that are made to the projects table, for example, for the projects collection. So we will have 3 different shape URLs for the 3 different collections. Great. So at this point, we have connected Electric to our database. This part of the job is done. The next one is creating the Electric proxy. For that, I'm going to come here and just clone the project that I prepared. Let's go into it, and actually I have some files that I want to copy here. So the first one is the file for the environmental variables. The electric URL is the only variable that is public. This will be probably the value for you too here. Now let's look at the table. Yeah, let's look at this file. Many things are missing. First of all, pnpmi to install the dependencies. There will be one that I know we don't have in package.json yet, and there will be also this pnpm dev command that we have to run because this is a TanStack DB app and the routes need to be generated. So perfect. We come back and okay, so let's talk about this file. This is what we are going to use for the proxy routes. Now the URL for this file contains a dynamic param, the table, this one. It will match any route looking like /electric /boards or to-do items or projects. These are the names of the tables. In the next part, we make sure that we have all the environmental variables available. Then we create the URLs. The first one is to copy the data from this request to the next one, and the second one is actually the URL where we need to forward the current request. This part is where we make sure that every electric specific query param will be copied to the new URLs. This variable is imported from the electric-sql client. Then we will have to set the table and the source. This is from the environmental variables. Great. Then we send a new request to electric, and yeah, basically the electric API secret is authenticating our request to electric. Let's look at the diagram to see where we are in the process. We've just implemented the electric proxy. This has been already done. The next step is to switch from the query collection adapter to the electric collection adapter in every collection. I'm just going to head back to my editor and let's open up the projects collection. What do we see here? We see that we're using the query collection and we want to change that. First of all, let's remove the query DB collection. Then let's add the TanStack /electric DB collection. So this will, cool. So now if we restart the LSP server, we'll see that we will have some errors. First of all, obviously this thing have to go. We don't need the query collection options anymore. We need the electric collection options. Now that we have that, we can move on and delete the query function because we don't need that anymore. We also don't need the query client and the query key. What do we need then? We need a schema, which will be the project schema, and we also need the shape options. So the first thing we'll put here is the URL from which we'll fetch the data for this collection, and this will be the proxy route, specifically the one for the projects table. This is a table name. Now, another thing we might want to do here is to use a parser for the timestamps, which is this one. Okay, and now we need a column mapper, because if you look at our DB schema definition, which is here, you will see that, oh, this is a good example. You can see that the name of the created add is in camel case in JavaScript, but it's in snake case in the database. So we want to use the snake camel mapper function here. So snake camel mapper will make sure that we won't have an issue because of the casing mismatches. Okay, this is almost ready. I will clean up the stuff that needs to be cleaned up. Now it's all nice and beautiful. There is still one thing that we will have to do later, but before we do that, let's update all the collections and see how it goes. Awesome. So at this point, I think we should get all the data we need for the collections from electric. Error projects is not a valid URL. Yeah, basically we need to get an origin for this URL. I will create a file. It will be called Proxy origin. Run this on the client. Awesome. So now that we have this, we can just go to the collections and update this to proxy origin slash and whatever we had before. And this way, all of these will be valid. So let's go to the to-do items and go to projects, to-do items, do the import, and I think we have the boards. Yeah, we have the boards. Add the import, and the projects there should be boards. And boom, we have everything we need. So let's test the scenario where we update this client and expect the update to pop up automatically in real time on the other client. So updated project, and boom, it's updated. Now we saw a little bit of flicker there. The story behind the flicker is that when we rename a project, the local cache gets updated immediately with the optimistic state, which is the new name, and the patch request will be sent to the server. And when that request gets completed, the optimistic state will get removed from the local cache. However, Electric didn't have time to pull in the changes yet, so in that gap between the patch request being completed and Electric pulling in the changes, you will have a short period of time when you see the old state, and that is the flicker. What we need here is to tell Electric that we know about a successful transaction in the database and we don't want it to update the local cache until the results of the successful transaction come in. The docs recommend you to use transaction IDs for tracking transactions, and we will have to get the transaction ID from the API route where we update the transaction, and then we can use that transaction ID to wait for the sync. Things are moving crazy fast because I haven't even published a video and we already have some updates in the API. Previously we had to return the TXID, but now we just have to run the waitTXID method to make sure that the flicker doesn't happen. I will go now and let the old video play, but when we come to this part, I will make sure that I jump in and we use the new API. So let's do that. First, we will have to go back to the editor and let's look at the projects collection and see where this is where we do the update. Yeah, so the route where we do the update is API projects, this one, and here we will go to the patch handler. Yes, this is it. So let's find the part where we update the database, which is this one, and I'm using Drizzle, so I will have to do this the Drizzle way. Await db.transaction. Here we will have an async tx. Yes, cool. So this part can be put here. Let's return the updated to. Here I will have to put these lines. And well, if you don't know Drizzle, this will basically run this SQL code in the database and return the result. I copied this from the official skill of Electric. These are the lines. I also see here that for some reason they convert TXID to an integer, so I will do the same. Let's head back and say that I return TXID, which is parseInt TXID, and also updated. Cool. So what we want to do here is to return a response.json and let's return the TXID. I don't think we're interested in anything else. I think there is some dat code. Yeah, there is some dat code here. Not anymore. So let's head back to the projects collection and use the TXID that we just got here. I think I will put the new code here. So first of all, I want the JSON content So this have to be awaited. And then I can just do something like const txid equals z.object, and then txid, which is a number, we know that, and we will just parse this and the JSON response. Okay, this is it. So actually we will return the txid, and that's it. We will have to make some changes. First of all, I'm going to need the collection here, and I will delete this part where we return the txid, and I will await collection.utils.await txid, and this will need the txid. Sorry for the interruption. I will give my mic back to the old me. At this point, I am not expecting the flicker to happen anymore when I rename a project. First, we will have to update this stuff. So no flicker for sure, and no flicker for sure. Are you sure? It is absolutely sure. And this is it. So every persistence handler will have to be updated in the code base with the transaction ID stuff. I will not do it in this video, but I will do it later. The link will be in the description, or I don't know, somewhere. Okay, so let's talk about the pricing of Electric Cloud. It came out as I was editing, and man, it is good. So first of all, you won't have to pay for reads, you won't have to pay for the egress or fan outs. So you have basically unlimited clients for free. What you need to pay for is writes and data retention. Electric could become the standard for applications like live news feeds that broadcast the election results, because they have millions of clients, not a lot of writes, and not a lot of data. So it's very ideal for this. What's really good is you don't have to pay if your bill is less than $5. $1 per million writes, 10 cents per GB month is not a lot. So I think this is a good deal. I like everything about it. I almost forgot to mention that Electric is not burning VC money to make reads free. It's actually using CDNs, so it's very cheap for them to do this. And that's it. This is the video. I hope it was good. It took a lot to film and edit it. Please be nice in the comments. If you have any questions, you can tag me on Twitter. It's @notacheetah. And I'm looking for TanStack related video topics. So if you have any, please just send it my way. I will check it out. And if it's a good fit, I will make the video. My website is fullup.dev, and I have nothing else to say, so bye.